it seems to have become more variable, and the oscillation seems to have increased in amplitude. Can everyone see that? So in the last million years, it seemed to follow the 100,000 year cycle that I pointed out before. But before 1 million years ago, and up to 2.5 million years ago, it seemed to follow a 40,000 year cycle. And before then, it didn't seem to follow any of these cycles at all. So, kind of neat.
So that's ocean core.
This is ocean sediment core. Okay, so this is the oxygen isotope paleotemperature proxy based on the ocean sediment core. So it's actually reverse of the ice cores. So as we go to smaller numbers, that means it's getting warmer. Okay, great question. Okay, so that being said, I told you I was an astrophysics student. So the possible cause of these cyclical patterns in the coming and going of ice ages may have an astronomical theory behind it. And Milutin Milankovitch, a Serbian astrophysicist in the 1920s, produced Milankovitch orbital theory, and he proposed that the advance and retreat of continental glaciers in the world was based on changes in the Earth's orbit around the Sun. So there are basically three cycles. The first is eccentricity of the Earth's orbit, and that's the shape of the Earth's orbit, which varies between being relatively circular to more elliptical over about 100,000 year cycle, and it's caused by the gravitational influence of the other planets in the solar system. So once in a while, the Sun, Earth, and Jupiter will all line up in their orbits, and Jupiter's gravitational field will tug a little bit on Earth's orbit and pull it a little further away from the Sun. Right? Okay, so all the other planets in the solar system gradually alter the Earth's orbit, and it changes the shape of the Earth's orbit over about a 100,000 year cycle, and it affects the total amount of solar radiation received by the surface of the Earth over the course of the year, based on Kepler's second law of planetary motion. Does anyone know what that one is? So planets sweeping out equal areas of the ellipse at equal times. Okay, so if it's more elliptical, we're going to be spending more time in the further section of the ellipse and less time in the closer section, right? Okay? Because we have more kinetic energy when we're closer to the Sun, so we're moving faster. We're moving slower when we're further away from the Sun. So we tend to collect less solar radiation over the course of the year when it's more elliptical, but only by about 0.2%. It's not a very big number. Okay, moving on. Next cycle is obliquity, and that's the tilt of the Earth's axis. So right now the Earth's axis is tilted 23.5 degrees with respect to the plane of the solar system, but this varies between about 22 degrees and 24.5 degrees over about a 40,000 year cycle. And it's also caused by the gravitational influence of the other planets in the solar system. So, sorry to burst anyone's bubble, but the Earth is not a perfect sphere. Okay, it's flattened at the poles and it bulges at the equator. It's called an oblate spheroid. Oblate spheroid. Okay? So, once in a while, oblate spheroid is tilted. Once in a while, another planet will come within the vicinity of the Earth and tug on the Earth's equatorial bulge and shift it around in its orbit a little bit. Okay, does everybody get that? So, that gradually affects the tilt of the Earth's axis over thousands of years. And it affects the severity of the seasons, right? Because the main reason we experience seasons in the different hemispheres is because the Earth's axis is tilted 23.5 degrees. If it wasn't tilted at all, we'd hardly experience any seasons. So the more tilt you have, the more extreme the seasons are in the different hemispheres. Everybody follow that? Okay, next. Maybe I'll also point out that we're kind of right in the middle of the obliquity cycle. And the last obliquity maximum happened around 15,000 years ago. That's when the Earth's axis would have been tilted about 24.5 degrees with respect to the plane of the solar system. But next, my favorite cycle, it's called precession, sometimes referred to as the wobble of the Earth's axis. So if you think of a spinning top, when you spin a top, it starts to lose rotational energy, and the rotational axis shifts to one side, and the rotational axis precesses. Right? Does everybody understand this? So the Earth's orbit kind of does this over thousands of years as well. It's caused by the gravitational influence of the Earth, gravitational influence of the Sun and the Moon on the Earth's equatorial bulge. causes the rotational axis of the Earth to trace out a circle roughly every 25,000 years. And it also causes the north celestial pole to trace out a circle in the sky every 25,000 years. So right now the North Star is Polaris, but 12,000 years ago the North Star was actually Vega, another bright star in the northern hemisphere. So it's really neat. It causes the north celestial pole to trace out a circle around in the sky every 25,000 years around the constellation Draco.
Do you have to compare this to the combination of tilt and then precession, how that you've got something that's
Yeah,
and it's precessing, you want to say that the tilt is constantly changing as well.
yeah.
So what's the time compression and the time difference in this variation versus this?
Okay. Obliquity varies between 22 degrees and 24.5 degrees over 4,000 years.
Precession is
25,000 years. Okay. How does it fit together? We're going to get to that. But great question. Okay, so precession also causes something called the precession of the equinoxes. Anybody ever heard of this? Precession of the equinoxes. So back in the 60s, there was a lot of talk about, well, we're entering the age of Aquarius. And there was the song and all the hippie stuff and the long hair. I wasn't alive then. I don't know if any of you remember this. Maybe you're around, but you don't remember. And anyways, it was based on the precession of the equinox. Okay, and that's just the position of the Earth's axis changing with respect to the stars at different times in the year. So spring equinox used to occur when the sun was in the constellation Pisces. Now it occurs when the sun is in the constellation Aquarius. Okay? And I'm going to briefly explain to you how precession may affect climate over millions and thousands of years. Okay. So going back to this, the Earth's orbit is not perfectly circular, it's somewhat elliptical. And the point in the Earth's axis when it's closest to the sun is called perihelion, and that occurs around January 2nd, during the northern winter and the southern summer. But 12,000 years ago, because of precession, the northern hemisphere was actually pointed towards the sun at perihelion. Okay? So that would have been the northern summer and the southern winter. Okay, so what does this mean? Well, you have more melting in the northern summer, right? Because the northern summer is now occurring when it's closer to the sun, and it used to occur when it was further from the sun. Okay? So there's more melting of the glaciers in the northern hemisphere. And there's more land mass located in the northern hemisphere, and it's easier to grow glaciers on continents than in the ocean, right? Does everybody see where this is going? It's all coming together now? So 12,000 years ago would have been around the time of the precessional temperature maximum, if you want to call it that. So that's when we would have had the northern hemisphere pointed directly towards the sun at perihelion, so we would have had maximum melting in the summertime. Okay? And according to that, we should actually be somewhere near a precessional temperature minimum. We should be actually in the cool part of the cycle, because we have less melting in the northern hemisphere in the summertime. Okay? So, very good. Now some of you might have questions about ice ages, but hold on, because I have some questions for you. So remember I said it was a theory, but it's just a theory, and there's still a lot of things we don't understand about ice ages. But for starters, one of the most convincing pieces of evidence for the astronomical theory of ice ages is this. It's called the Vostok power spectrum. Does anybody know what a Fourier transform is? Yeah?